Okay, so if we can quiet down in the house, we have our final team, and then we're going to have a fantastic keynote speaker, professor at Harvey Mudd, Dr. Colleen Lewis, who specializes in studying computer science education, among many other things. And she will be giving us a speech with time for questions while the judges deliberate outside. And after that, we'll have a reception with food and can hang out for a while. So without further ado, after I give the schedule, who should I hand the mic to first? eMISSION Control.
Hi, I'm Victoria Tran. I'm going to be a senior at PHS, and this summer was my first year using Python.
Hi, my name is Adriana Bank. I'm an incoming senior also at PHS, and this is my first experience with coding in general and with Python and everything, but I've had a great experience.
My name is Charles Dowell. I'm going to be a junior at PHS, and this is my first time with Python.
Hi, my name is Moaz Mokri. I'm going to be an incoming sophomore at PHS, and this is my first time coding.
And my name is Janelle Juarez. I am a math teacher at Pasadena High School, and I came in with an introductory level of Python.
And we are eMISSION Control.
Someday, our children and our children's children will look at us in the eye and they'll ask us, did we do all that we could when we had the chance to deal with this problem and leave them a cleaner, safer, and more stable world? Barack Obama, June 25th, 2013. These are personally some of the words that I try to base my life around and why I wanted to do this project, but we all had one common goal in mind, to bring awareness to this invisible killer and to ensure a better future for our future generation. But let's get on to our project scope. Okay, so our project objective was to show the effect of aerosol emissions, to show the effect aerosol emissions have on human health, as well as to show the effect of current legislation on aerosol emission regulation. How we did this project is that we took satellite imagery and we compared it to data with states of health and frequent ailments to find a correlation between them.
So we were interested in the legislature aspect of it, and so we wanted to look particularly at carbon emissions, which are caused by burning of oils and coal. So we were interested in looking at that. As Momo stated earlier, we did focus in particular on aerosol emissions instead of something like carbon monoxide or carbon dioxide. And he said that we were looking at how it affected health. So we specifically focused on respiratory health. In particular, we looked at asthma, and we also looked at COPD, which is the third leading cause of death in the United States.
Okay, as I said in the project scope, we used satellite imagery to do this project, but we specifically used two satellites, Aqua and Terra, which both had aboard the same instrument, which is MODIS, and MODIS is the instrument which displays air quality worldwide, but we just used the images displaying North America.
All right, so what we did is we downloaded these images from the satellites. We would take them and analyze each one pixel by pixel. We would then compare it and try and get a concentration level as a percentage value. And then we were able to plot that value against some different variables. And the variables we chose to compare it to were COPD as well as asthma in the United States. So we compared it over the years 2005 to 2015. We compared them, and we were able to get a visual representation about how they correlate. Moving on to the coding. So in this first snippet here, this is the code, some basic code we use to graph all of our data. We used the constant x variable of year so we could measure its time. We went from 2005 to 2015, as I mentioned. Then further on, the other variables we used were asthma prevalence. And then the thing we were comparing it to on the other side of the y-axis, as you'll see soon, is the air pollution that we found with our code. So what this is doing, it's getting those images. We're taking those arrays of information that we were working with, we're plugging them in, we're titling the graph, and then we're graphing it, and then we're going to display it, and you'll get to see the graphs in just a second. So in this next bit here, what this is doing is it's trying to find the correlation coefficient with our code. So that way we could try and see just how directly it correlates statistically, entirely statistically. So what this is doing, we're plugging in our x and our y, and in this case for x, and for our x and y, we're using the COPD asthma, and then the other variable, we're plugging in the air pollution that we calculated. This allows us to get a representation about just how directly this information is correlating together. In the next slide right here. So this is basically the main bit of code that we use for our entire project. It's analyzing each pixel and checking for a specific RGB value, making sure that it fits what we're trying to search for. If it matches what we're looking for, we're taking that, we're calculating it to return a percentage, which we were using to plug into that graph right back there. So it's downloading the image, it's analyzing each one individually, and it's returning it as a percentage. And we're doing this across many different dates. So next, right here, this is the basis of all of our code that everything was based off of. We were using the NASA Gibbs tool. This enabled us to we were able to get not only specific locations, but the exact times we wanted and the exact instruments we wanted. So that allowed us to get not only different locations in North America, but we were able to use different instruments to try and look at this information.
Okay, so these are data and findings, and we plotted them using the matplotlib module in Python. And our first graph is aerosol content versus asthma rates. And for the x-axis, we chose the years 2005 to 2015. And for our first y-axis, we have our asthma rates, which were taken from the amount of people who have asthma over the total population in the United States. The next y-axis is the average aerosol fraction that we gathered using, that we computed using our code. And what we did was look at the RGB values and pick out specific colors and took the number of pixels that had that certain color over the total fraction, the total amount of pixels. And that's how we got our fraction. And the vertical line is the date of Obama's executive order 13653. And this executive order was intended to increase our preparedness and resilience against climate change. And the climate change factors are extremely significant for communities that suffer from economic challenges or health-related issues. And as you can see, we focused on 4 areas of the United States: the Northeast, Midwest, South, and West. And you can see them plotted on the dotted lines. And those are the asthma rates for each region. And as you can see, after 2013, there's a decline in aerosol content. And for asthma rates, they began to plateau. However, with this code, we picked for our aerosol content, we examined one day out of each year. So to make our code more accurate and more representative of the year, we made a secondary graph. But this time, we took multiple days out of the year and averaged it out to get a clearer representation of what the aerosol fraction was for that year. And as you can see, after 2013, there's a similar trend in the aerosol content declining still. And these 4 graphs are the aerosol content and asthma rates, but they are taken by region. And we did this so we could get a clearer image and we could examine the distribution of pollutants in the atmosphere or the amount of asthma rates by specific region. And our first region is the Midwest with the lowest correlation coefficient. And the image here is from what we gathered from our satellite, the Aqua and Terra. And it ranges from deep purples and blues, which are the most severe areas of pollutants, to the blues, which are moderate, and the greens, which have the least amount of pollutants. And as you can see, after 2013, there's still a decline in the aerosol concentration and a plateauing of the asthma rates. Compared to the previous years, it's lower. And our next area is the Northeast, and this one had a higher correlation coefficient. And after 2013, there's evidently a decline in both of the asthma and aerosol concentration, and we attribute that to Obama's legislation. And the next area would be the South, and we have the same decline after 2013, and we noticed that the aerosol concentrations are higher along the coast. And lastly, we have the West, and the aerosol concentration are also more severe along the coast, and we hypothesize that this is due to more industrial centers and access to ports. And this had our highest correlation coefficient. However, this graph, unlike the other graphs, actually has an increase at the end. And besides asthma, we focused on COPD, which is a respiratory disease, and it's as mentioned, it's the third leading cause of death in the United States. And we plotted it against aerosol content, and as you can see, there's similar peaks and dips. However, it seems to be shifted by a few years, and we hypothesize that this could be due to the amount of time it takes, because COPD needs prolonged exposure to be contracted. And essentially all these graphs were based upon our aerosol data that we gathered from our code that counted the color pixels from the satellite. And we have to account for possible areas like inaccuracies in terms of the noise in the images. However, there's clearly some visible trends, especially after the legislation.
Okay, so on to the impact of our project. Climate change has increasingly become one of the more urgent issues of contemporary America. We have noticed the recession of glaciers, forests, rainforests, costing animals their habitats. We have noticed more extreme patterns in weather, consisting of severe heat, sudden rainfall, and persistent droughts. These are all visible effects of climate change. Yet what our project focuses on are the invisible effects, those that cannot be seen with the naked eye. Our project shows that there is a correlation between human health and both the substances that cause climate change and climate change's consequences and effects. We hope that by bringing awareness to this, people will realize the necessity for environmental legislation and the danger that may be posed by our current president's repealment of these measures. Without regulation, this may very well become an irreversible mistake.
All right, so moving on to some predictions, we're going to begin with the political aspects. So some things to keep in mind is in this current presidency, we've canceled the rule for reporting methane and greenhouse gas emissions. We've also left the Paris Climate Accord, as well as getting rid of the Clean Power Plan. Another thing to mention is the Keystone and Dakota Access pipelines, both of which are potentially very destructive to our environment and don't actually create that many permanent jobs.
Okay, we can help stop this, but we must petition, march, and write letters to senators because we need legislation. But we should also inform ourselves about our environmental conditions.
So while we were researching about the effects of aerosol, one of the things that we found was that prolonged severe exposure to aerosol leads to the depletion of the ozone layer, which we we assume would cause a plethora of other environmental issues. So one of the things that we would like to explore maybe in the future is aerosol's effect on the environment, on weather changes, so extreme temperatures, droughts, different storms, and we would also like to investigate other geographical areas, especially those areas where there's not as many environmental regulations as there are in the United States. So maybe looking at places like China or India or Latin America. And we also wanted to investigate its effect on climate change in general.
Okay, so there's some medical considerations that we'd also like to bring up. So one thing that we found in our research is that the rise in temperatures due to global warming, which is also related to aerosol emissions and all of these emissions that we've mentioned, they're likely to allow for more plants with higher pollen concentrations to multiply, and this can lead to the severity and more frequency of asthma attacks and of allergies, which is very dangerous to a lot of people, considering the fact that we've shown that just with our data of aerosol, it does affect asthma rates and COPD. So we just would like to keep that in mind as well.
And also, as mentioned before, the pollutants do diminish and affect our ozone layer, and we'd also like to investigate the possible signs of humans being more susceptible to skin cancer as a result. And if we plan to extend our project and work on more code, we'd want to utilize either the NASA API or the Planet API to possibly, well, the modules to possibly get more images of the terrain itself, because we think it's important to monitor our levels of urbanization, and it's often tied to patterns of industrialization and pollution. And that image up there is from our code from the NASA API module, and we could basically see some patterns of the human imprint on our landscape and possibly use that data to gain an insight in the areas that we want to observe more. And that image is from the Landsat 8 satellite.
Another thing that we would have liked to delve into but didn't have enough time, given the fact that we had 2 weeks and we only have 3 work days a week too. So it's like we would have liked to also include carbon monoxide and carbon dioxide emissions, because that could definitely have some correlation with asthma rates, and maybe we could have looked at allergy, and like Victoria mentioned, due to the depletion of the ozone, we think more people would be susceptible to maybe skin cancer, and look at those rates as well, because these are all important to note with our changing climate.
And since we didn't get time to implement all our ideas, we documented our code and we pushed it onto GitHub, so that maybe in the future one of us or any other contributors can help develop our code and make things more statistically significant or implement any of these ideas. We think projects like these are essential, and that we need to look at patterns between the Earth and human interaction to possibly find predictions and trends about ailments that we might gather, or the effects of legislation on our environment. And yeah.
So join us
In creating
A cleaner,
Safer.
More stable world.
So I will open it up for questions, but I did want to say one thing to congratulate eMISSION Control. They had the most open-ended project. Other projects were kind of given a data set and some ideas of what to do. eMISSION Control was asked to use NASA data and human factors data to tell a story. So this story, it's our story as humans, but it's also their story entirely. So thanks a lot, and we'll open it up for questions. Nico?
Isn't that satellite image of Caltech directly over Caltech? I believe I got an image there and it looked the same.
For our example, we just chose a random image, and I just chose Old Town Pasadena. So
They're talking about this one.
Good eye. Other questions? Yep.
I have a question about how you guys decided to delineate the work and break it down among yourselves and what you all worked on individually.
So we actually took turns like doing code. So one day we'd all collaborate ideas. The first day it was really hard because like Christine said, we had a very open-ended prompt for our project, and we didn't have any data sets to work with. We didn't have like a specific thing to do. It just said to compare two sets of data. So the first day was just spent with everyone coming up with ideas and two things that could be related. And so we sifted through tons of data sets all together, and then we came up with one project, and every day we had different leaders, and those leaders would assign roles based on our strengths, because some people were better at maybe matplotlib, some people were better at like getting images, so it was just based on our strengths and based on what people were more interested in, and we all worked together to with the final product, and made the slideshow together as well.
There was a question back here.
I think everyone today was amazing, and one of the things that jumped out at me about yours was taking complex data and visualizing it in a way that tells a simple story is a very powerful skill. And so my question to you is, as you were doing this, you obviously started with these image data, a lot of complex things, high dimensional, and you ended up showing relatively straightforward, simple line graphs. What was that process that you went through to kind of figure out what it is you wanted to show to tell that story?
I'm curious about this too, so very good question.
But we decided, well, I'm assuming the question is basically why we chose these two data sets to compare, correct? Or like what we decided to show, right?
Well, you started from a complicated data set and you showed it.
Oh, okay.
How did you funnel that down?
Okay. We wanted to show what we thought would reveal to everyone else that there's actually dangers that people don't really realize, because like I mentioned, there's so many physical things that you can see, things that you can feel, like you feel it getting really hot outside. Just the other day there was like a thunderstorm randomly in the middle of summer, and so these are just really like obvious effects, but we wanted to show those that are less obvious and those that people don't really think about, which is like allergies. Like you don't think like that's that, you know, I don't know, dangerous, and you don't think that asthma is like that dangerous, like you kind of forget about it. But we wanted to show like that legislation actually affected this. Like there was noticeable dips. Of course our data wasn't like as very accurate, but just because like we're all like not that experienced, but even our data showed a noticeable dip. So we just wanted to show something that would prove to everyone that like, oh, there are actually like things that can happen due to this in health, like that directly affects humans, because a lot of people don't realize that, especially with a president that says like global warming is a hoax and things like that. So we just wanted to bring awareness to that and represent the data that best suited that purpose.
Basically, with the data we had, graphing was just the most approachable way to go about it, because the visual representation of like the peaks lets you view it way better than just looking at the like pure numbers. Like because we can control the axes, we can control the minimums and the maximums. It lets us like line it up as best as possible while working with the same accurate data. So it gives you the best representation without stretching anything.
All right, maybe we can take one more question. Yep, Nayeli.
So you guys talk about Obama's legislation. So now this year that Trump is in in terms. So basically, I know you guys did it up to 2015. Now that, could you guys possibly, if you guys added like another 2 years or whatever, could you guys possibly know how drastically has changed over just this last 6 months?
Well, I'm sure you guys don't know the answer. Okay. Well, we were able to get the aerosol data up to 2017, but from the CDC, they only had asthma rates up to 2015s, and we're not able to monitor like the amount of reported diseases since after 2015. So that's why we just kept that same span of time that we wanted to observe and narrow down to. But I think it was just important to show at least 2013 so you can see the effects of the executive order and how significant it is that these environmental regulations are at risk of being repealed.